Let's begin. And this is the contact information for myself and Primus Wind Power right here on the screen. Also the contact information for Renvu. And they are, again, a off-grid and grid-tied distributor that we work closely with and sell our products as well. And so with that, I'd like to invite, I believe Nick is with Renvu, and he will be discussing these first two slides. Nick, go ahead and unmute yourself.
Yeah. Hi, everybody. Thanks, Ken, for the introduction and for taking the time to do this webinar today. We really appreciate it. Quick overview of Renvu. We were founded in 2012, initially starting off specifically in grid-tied solar distribution, and as we've grown as a company over the last 8 years or so, we've expanded into a number of different areas in the renewable field, wind included. So we have a pretty in-depth knowledge about a number of different areas, and we're happy to help in any way with design, engineering, and support as best we can. We've got fulfillment centers located in California, Texas, and New Jersey, so we have a pretty good reach to be able to get products to you with relatively short timelines from anywhere in the country. Our sales team is comprised of engineers, the idea being that they've got the technical background and understanding to be able to actually provide you with the information you need and the design guidance you need when taking a look at a project, and to be able to talk intelligently about those products. So instead of selling you a project, they're actually discussing it and finding what works best for your needs. In addition to that, we have several free online tools that allow you to design projects, generate bill of materials, and gives you a lot of flexibility in terms of being able to make revisions, go back and forth, and play around with different design ideas you might have. There's some links here, and you'll have these links when we send everything out afterwards as well, sort of recapping the webinar. You can go to our website as well, www.renvu.com, and the first thing you'll see is the solar kit guide. So on there, that gives you the ability to go through and design not just for solar, but with energy storage and wind as well as options, both grid-tied and off-grid, to be able to design and put together a quote within 5 minutes. So it gives you the option to do that very quickly. And from there, you can then talk with one of our sales engineers to kind of go more in depth and discuss it. Some of the larger tools that we offer, aside from just these design tools, are some professional engineering services, on-site analysis, permitting and engineering design work, as well as logistics and warehousing solutions. So we have our primary fulfillment centers, but we have a relationship with a number of different 3PLs around the country as well. So if it's something that you need assistance with on a project where you may not be able to receive the material timeline-wise right away, we're certainly able to help with storage and working out that delivery timeline. And the last thing there, purchasing excess inventory. We often hear back from customers that they wind up having leftover inventory and they're not sure what to do with it because it's maybe outdated or doesn't fit in with any of the designs they're working on. So we frequently will do that as well, just as kind of a service to try and reincorporate it back in and make sure that our customers aren't taking a loss on excess product. Yeah, so kind of a quick overview of some of those services and tools. Cool. Thanks, Ken.
All right, thank you. All right, let's get right to it. Here's what we're going to do today. Hopefully you'll find this educational, interesting, as well as helpful to you if you're thinking about going off-grid. I'm going to tell you just real briefly about the AIR. Some of you guys might remember a little bit about the AIR. It's been around a long time. The specs of the AIR products, so you know that. And then we're going to talk about turbine components, types, blade sets, applications, not just the AIR, but just kind of general overview of wind, kind of a wind 101, siting and towers. And so that, you have options of either, the Primus products, or I'm also going to teach you about just wind in general, operation, installation of our equipment. And really importantly, when you're thinking about wind, the first thing you want to know is how to determine a wind resource. And so I'm going to give you a tool, a free resource tool that Renvu or Primus can provide for you to determine your wind resource in your location. Why hybrid is a good idea, why off-grid is maybe a good idea for you or maybe not. And then we'll finish with some installation examples, pictures of different types of towers, installations, and so on. And then the last thing will be questions. So here's the product itself. We've been around a long time, 25 plus years. We started out with a product called the Air 303, then we moved to the 403 and the Air X and the Air 30, which we still have, and the Air Breeze and the Air 40. I'm going to talk about all the different, we have 5 different products and what the differences are between them. And then we have the Air Silent X. The nice thing about the Air product line, it's made in the USA, of course. That's proud of them being an American-made product, made in Denver, Colorado. But we have 175,000 plus units out in the field. So we have ASDs all over the world. That's authorized service distributor. And so you can get parts and pieces anywhere you are, which is really helpful for especially people who are in very remote locations or on sailboats or whatever. And we've had many generations of improvements of the product since it's been around for such a long time. Here is the product's tech specs itself. So it is a 1 meter swept area turbine. The rotor diameter is about 1.2 meters. That's how big the blade set is, 1.2 meters, 46 inches. So we call it a micro turbine. So you have these turbines out there. Typically, if the turbine is 1,000 watts or below, that's somewhere around 2 meter rotor diameter below. That's typically called a micro wind turbine. And anything from 1,000 watts up to about 5,000 watts or 5 kW turbine is usually called a small wind turbine. And then above that, you have larger wind turbines. So that's just a little definition of what the area is we're talking about. So we're a micro wind turbine. It only weighs 13 pounds. So it's very small, very portable, very easy to install. The startup wind speed for our turbine and pretty much most turbines out there, unless they have a specific boost function where they actually push the blade sets along, is about 7 to 8 miles per hour. And that's always at sea level. So every wind turbine is the cut-in speed or the startup speed is at sea level. As you go up in elevation, you lose about 3% per 1,000 feet of efficiency. So because of the density of the air, we'll talk a little bit more about that. But so any wind turbine that says they cut in lower than that, which a lot of, especially Chinese turbines say that, they may start spinning, but the reality is there's not really much power in the wind below that 7, 8 miles per hour. You really need to get up to 10, 11, 12 to really have some, good usable power and amps, in our case, off-grid in the wind. So all of our turbines are a micro-based smart controller. It's up tower controls. So I'll talk a little bit more about that. The body is an cast aluminum housing. We have different blade sets. They're either injected molded composite or a fiberglass or other types of configurations for the blades. We have an electronic torque control, which is means that we have a direct short to the windings in the stator. Is how we stop the blade set. It is not a mechanical brake. It's an electromagnetic brake. That's how it works. And all of our turbines mount on a 1.5-inch Schedule 40 or Schedule 80 pipe. And we're really proud of our 5-year warranty. So here is one of our turbines. This is called the Air Silent X. It has this a fancy carbon fiber hand-laid blade set. It's designed to be super quiet. That's the whole point of the Air Silent X. It's designed for the sailing market, the cruising sailboat market, where sound is very critical. So it's 40 decibels approximately is the output of sound, which is very quiet. Typical dishwasher is about 50 decibels, right? So it's very quiet. That's why it's called the Air Silent X. Now you can upgrade any of our turbines to this blade set. So if you have a turbine and an older Air X or an older turbine from before and you want to upgrade, you can do that with this blade set. Here is the turbine itself. Let's talk about what this looks like. So all of our turbines are upwind, horizontal axis, up tower controlled turbines. So upwind meaning you have upwind and downwind turbines. Our turbine is an upwind design, and that means that the flow of the airflow, the laminar flow of wind comes this way, hits the nose cone first, and across the blade set. It is a 3-bladed turbine, which is the most common, most people would say, efficient design for high wind and low wind environments. Then you have your bearings. Here's your stator. This is the copper windings. And this rotor right here is what slides into the stator, and that's wrapped with magnets. They're neodymium. It's a rare earth magnet, and that's what the turbine, the hub is connected to, this rotor, and the blade set turns, and that spins around the copper windings, which produces the wild AC. That's the electrical charge, and it is AC at this point. It's an alternating current, and then it goes into this circuit card. This is the microprocess controller. This is the up tower controls of the turbine, and it rectifies that wild AC to regulated DC. And so what comes down tower in our turbine is 12, 24, 48 volt DC. That's the design of the air turbine. Here's the body itself, also called the nacelle, and then you have the tail here, which keeps the turbine, as we say, on the wind. And that's why it's an upwind turbine, because as the wind changes direction, the tail, the wind hits the tail and pushes the blade set and the face into the wind. We have these. This is your yaw bearings right here, and then you have your yaw itself. This is where you slide the pipe, the 1.5-inch pipe, into the yaw, and then you clamp it down with these yaw bolts. And then down tower through the pipe comes the 3 wires, the red, the green, and the black. And that is the positive, the negative, and the ground. And so that's how our turbine works. Again, it's a DC turbine. And everything, all the controls are up tower, so you don't need a down tower controller like you do with solar. So here's what they look like. Again, 13 pounds, 1.2 meter rotor diameter. This is the land version. It's a gray cast aluminum housing. Here's the marine version on the right side, which has a aircraft quality paint. It's for a marine environment, and we recommend with our turbine or any turbine, if you're within 10 miles of the ocean or in a corrosive environment, then you need to upgrade to a marine turbine version. That's kind of the general rule of thumb, 10 miles of the ocean. If you were in Hawaii and you're 10 miles away from the ocean, I would still recommend a marine turbine because it is a highly corrosive environment. So this is a little spreadsheet of all the turbine types that we have. We do have 5 different turbines, and this kind of gives you an idea of which ones are for which. And the 2 things you want to remember is when you're thinking about wind, you want to know your wind resource, and then you want to know which turbine type is best for your particular application. And so sound falls into that equation. So here's the Air 30, one of our turbines. It's really for industrial, oil and gas, telecom, because it's loud. It has a blade set on it that's designed to be very robust in high wind speed environments, but the trade-off there is it is loud. It's over 100 decibels. You can add that blue blade set to it if you are in a high wind environment and you need the most robust turbine we sell, which is the Air 30. And so that's what you can do. You can add the blue blade set to an Air 30 and make it much, much quieter. The AirX Marine is just the marine version of the Air 30. Again, industrial, offshore, high wind speed, high sound environment. So the residential, education, small off-grid cabin, any place around people, land turbine is called our Air 40. That's kind of a low to moderate wind speed environment where it's around people or you're around the turbine all the time. That's the choice for you if that's the application you have. The marine version of that is called the Air Breeze, and that's for sailing or residential marine applications, things like that. That is also a low to moderate wind speed environment. The Air Silent X is our marine turbine. It's cruising sailboats. So if you're interested in the cruising sailboat actually being very quiet, that is our quietest turbine we sell. It has those blue blades, very low sound, but typically a cruising sailboat environment. These are the blade sets. I showed you the blue blades earlier, but you can see here, this is the Breeze Air 40. We just talked about that blade set. Here's the Air 30 Air X Marine. We just talked about that. You can see there's a distinct difference in surface area between these blades. That 30% more surface area here on the Breeze blade set. So it's designed for a low to moderate wind speed environment. So when you're trying to pick your turbine, when you're picking your turbine, these are all things you need to consider, right? Is what's the environment you're in, so you can have the blade set that's important, that's right for that environment. And so if your Air 30 blade set, it's going to be thinner. It spins at a higher RPM, 1800 RPM versus 1200 RPM for this one. So these things matter. So you want to make sure you go back to this and you look at what your application is and you pick the right turbine for that application. Let's talk about the hybrid system a little bit here. So hybrid means solar and wind combined together to charge your batteries to power your loads. Okay, that's what we're doing, hybrid systems. Here is a standard system only. This is like 3% of our sales is a turbine-only system. We rarely sell turbine-only systems because most people believe, and we believe, that combining solar and wind together makes a lot of sense, and you should have solar with any system because there's lots of times where the wind is becalmed and you don't have wind. And you don't want to have the big, huge battery bank because that's expensive for the times when you don't have wind. So having a hybrid system makes a lot of sense. So here we have, if you're not familiar with off-grid, here's a standard line diagram for off-grid systems. And so you have your PV solar array here. You have a charge controller, right? And you go through your ammeter, your J-box, fuse breaker, battery disconnect, and then down to your batteries here. So that's your solar only system. And then on the other side, you have your wind turbine. It's working separately, but both systems are looking at battery voltage. That's the whole point in an off-grid system with solar and wind. They're always looking at battery voltage. Your charge controller for your solar array and your up tower charge controller for your turbine. And this goes for many, many turbines, by the way. They either have up tower controls or down tower controls, but they're always looking at battery voltage because they don't want to overcharge that battery. So with the turbine, you have your 3 wires coming down. Again, it's DC, and it is voltage specific. So you saw in this previous slide here, guys, where I have 12, 24, and 48 volts, right? All of our turbines are voltage specific. So you order the turbine that's appropriate for, sorry about that, guys. I had a little. Okay, can you still hear me? Can you guys still hear me okay? Nick?
Yep.
Okay, thank you. So for a hybrid system, you want to order the voltage of your battery bank, as we discussed before. And so with the turbine, you're 3 wires down. You want the positive and the negative are going through a stop switch, a breaker, fuse to protect your wiring, battery disconnect into your batteries. And then you also have the green wire, which is your earth ground, right? And so they're 2 separate systems, but working very well together. Both of them are looking at battery voltage all the time. So that's how a hybrid system works, an off-grid hybrid system. Here on this side right here down in the corner, you can set your turbine up or set your system up with a diversion load controller, which then takes the excess energy after your battery bank is full and diverts it to a resistive load like a water heater or an air heater. That is an option. I would say only about 5% of our customers go with that, but you need a diversion capable charge controller like a TriStar 45 or a Xantrax C40 to divert off of your batteries. And in that case, you would set the PV charge controller up for a higher voltage regulation set point so it doesn't shut down, and same thing on the turbine. If you have specific questions and you want to do that, we can talk to you more in detail about that offline or after the webinar. all of our turbines have a potentiometer on the side of the turbine, and they're all factory set at these voltages right here, but they are adjustable. So when would you want to adjust that potentiometer, that mechanical set screw? Well, if you're going to be setting it up with a diversion charge controller like I just showed you, or if you have a lithium-ion battery and this factory set point is not appropriate for the battery set points in your lithium-ion manual, you can adjust that. Some sealed batteries will also want that adjustment. So you can adjust it out in the field, and we have very good explanation of how to do that in the manual, and that is possible. So remember, that is the case, but it does come factory set at these voltages, which for most batteries, even lithium ion, that is where you need to be. So here's that pot screw on the side of the turbine. And here is an LED light on the belly of the turbine that I want to talk about just for a second. This is the mechanical potentiometer screw on the side of the turbine that you potentially could adjust. And this LED light on the belly of our turbine gives you the functionality of the turbine, and I'm going to explain that, and this is also in the manual, but I'll explain that very briefly because I'm surprised many of our customers, when they buy a turbine and I ask them what the LED activity is, they say, what LED? So the LED is right here on the belly of the turbine. You can look up at it and see it. It's typically green or red, depending on the turbine. And if it's solid, not blinking, that means the turbine is spinning at high enough RPMs to where it's pushing amps to your battery bank. If it starts blinking slowly, that means it's in regulation, meaning the turbine has seen the regulation voltage set point, like 12 for a 12-volt system, that would be 14.1 volts, and it applies the electromagnetic brake, slows the blade set down. It's not a mechanical brake, so it won't stop the blade set, but it slows it down, and then the LED will begin blinking slowly. If it's blinking rapidly, that means you are in overspeed protection. All of our turbines, if the wind is too high, and usually that's above about 35 miles per hour of wind, the turbine will go in and out of overspeed. It'll test the wind. Depending on the turbine, it's anywhere from 2 to 4 minutes, and it'll test the wind, and it'll say, okay, I'm good to go, or no, apply the brake, shut down, let the wind die down. That's called overspeed protection, and that's a rapid blink. All of our turbines provide that function. So one thing that you can do with our turbine, it's an accessory. It's called the wind control panel, and I especially recommend this if you're not having an electrician install your turbine, or you're not very electrically inclined for installation. This makes installation very easy, and it combines 3 things that I think are important in any installation, which is an ammeter, a stop switch for the turbine, and a breaker. And so you can see here with the wind control panel, wind in, battery in, very easy wiring, and it allows you to have these 3 components. The stop switch is important. It's basically all marine turbines, sailboat turbines have a stop switch. They want to be able to shut that turbine down if there's a big blow coming in, if there's too much vibration on the boat, all kinds of reasons why you'd want to shut it down, maintenance purposes. But you'd want to use that same idea applies for a land situation where you need to shut the turbine down. It's very helpful to do that for many, many reasons. So a stop switch is a very good idea. Obviously, we talked about the breaker to protect the wiring, and the ammeter kind of gives you an idea of what kind of power you're getting out of the turbine. And our next version, we just came out with this a few months ago, is the digital version of this wind control panel. It gives you voltage, right? And I put a 9-volt battery in this and took the picture, so that's why it's showing 9.5 volts. It gives you current in amps. It gives you power in watts. That's instantaneous power in watts, right? And then it gives you energy over time in watt hours, which is resettable with this particular digital meter. It gives you the stop switch and the breaker. So this is kind of a nice thing to add to a hybrid system because you're going to get the data off from your system. Let's talk a little about, I get a lot of questions on maintenance of turbines. wind turbines in general. Usually most micro turbines, all of the bearings are sealed bearings. Ours are too. And there's really not a lot of maintenance for micro turbines. But there are a few things you need to do. You need to check your blade set. You need to see if there's any significant chips or dings in your blade set. It is a balanced 3-bladed set. So if you have cracks or chips in your blade that are significant, large, you would need to replace the 3 blades. You need to make sure the blade bolts are solid on the hub. You need to check that out. You need to check the yaw bolts that's connected to the 1.5 Schedule 40 or Schedule 80 pipe. You want to look at that. And you want to, it's a good idea to power cycle your turbine using that stop switch we just talked about, and confirm when you power cycle your turbine. Every time your turbine comes back on after power cycled down, you'll have 2 slow blinks, and you want to confirm those 2 initial blinks. And it's a good idea to do this on a regular basis every 12 to 18 months. So that is really the simple maintenance of micro turbines. And we have some great videos on our website under the service support tab where we show you how to do all this. Let's talk a little bit about tower height. And again, this goes for not just our turbine, but any turbine. Obviously, you want to be on as high a tower as you can get it. But with micro turbines, the sweet spot is somewhere between 25 and 45 feet. And the reason why that is the case is because if you go up much higher than 45 feet, you start getting into a lot of expense to put that tower up there. Not only the wire, because remember it's DC, so you're going to have a bigger wire gauge, right? But the cost of the tower, the cost of the guy wires, the cost of all that, and when you're talking about a turbine, a land turbine that retails for $950, it doesn't make sense to spend $2,000 or $3,000 on a tower. So it is important to get it up as high as you can. So you can see here, just going from 10 meters to 14 meters gives you an increase of 20%, an additional power increase, assuming good laminar flow wind on that turbine. So getting the tower up above that, what we call surface roughness, the ground clutter from the wind on the ground, is important. But what's really even more important is siting the turbine correctly. So this is the best place for this turbine because it's in good laminar flow wind. You can see those parallel lines that would be indicating, in our world, in the wind world, laminar flow winds. These lines right here indicate turbulent winds. So good laminar flow wind, so this is the best place for the turbine, right? If you get behind this building or behind a tree, you got to get it high enough up above those buildings and trees to get it back in the laminar flow, which is sometimes hard to do on a short tower. We have a rule in wind. We call it 20-50. You want your turbine to be 20 feet above and 250 feet away from any object that's going to cause turbulence. So that could be trees, houses, sheds, etc. So if you're, and you want to know, we'll talk about this more, but you want to know where your prevailing wind is coming from. We have a way to find that information out for you. But if you are not 250 feet away from big trees and stuff that's going to cause turbulence for your wind turbine, then you got to really consider whether is wind right for you. So these are all important questions, and that's why we teach this webinar, is to give you these things to think about. If you're on the water, like in this case, no surface roughness on the water, good laminar flow wind, lakes, rivers, ocean, those are all great places for wind. That's why a lot of the new mega scale industrial turbines are being put out on the water in the Atlantic and especially the Atlantic Ocean. So that's why wind off of the water really makes a lot of sense. Ridge tops are good because as the wind flows up the ridge top, the laminar flow compresses and that increases velocity. That's why you see these laminar flow lines moving together, and that increases wind velocity. So good idea to have it on mountaintops. A lot of good wind on mountaintops. And then here in this particular case, a plateau, a mesa, or a building, which we get a lot, is you get a lot of turbulence off the vertical faces of the plateau, mesa, or building. So you got to remember that anytime you have that vertical face, you're going to get turbulent winds, and turbulence is the killer of wind power. So if you're installing your turbine, which some of our customers do, on their barn or their energy shed, that you're going to get some reduction, and there's a lot of factors of what that depends on, but you're going to get some reduction in the power from the wind turbine, any wind turbine, that you're going to get into your battery bank because of the turbulent flow of that wind. That's what this is illustrating. So let's talk a little bit more about the hybrid system. I have a solar on my house in Flagstaff, Arizona. I love it. It's great, but it has some drawbacks. Solar has limited output during the winter months, has diminished output during bad weather, and obviously no output at night. So that's where wind power comes in a hybrid system, because the winter months are when you get a lot of the wind. Winter is great for wind power. There is higher density in the winter months, and if we can just get a little geeky, a little nerdy here for a second, I want to show you the wind power equation, which is right here. And wind power is three factors: air density, which we were just speaking of. The higher the air density, the more power you get out of any wind turbine. Wind velocity, which is cubed, right? So this is really the most important factor, along with swept area. And so the higher the wind speed, it's a cubic relationship, right? It's not linear, it's cubic. So when you go from 10 to 11 miles per hour, you really increase your power output. And then swept area is how big that blade set is. Our blade set, 1.2 meter rotor diameter. The bigger blade set you have, the more wind power, the more power potential you're going to get out of that wind turbine. So that's why air density matters. That's why wind power in the winter months matters. Wind is stronger typically during weather periods. The old saying, when there's weather, there's wind, actually does hold true. And wind does frequently blow on those long winter nights. So that's why hybrid systems are important. This is kind of the crux of it right here. Here's your summer, here's your winter, the complementary curve of wind and solar. We don't really wind in the summer months, the solar is doing all the heavy lifting, but in the winter months, you get that wind turbine in the mix, helping to push amps to your battery bank. So let's look at, this is a wind resource map for the winter, and the darker the blue color here in the United States, the stronger the wind speed, the higher the wind speed. And so you can see that the middle portion of our country, lots of industrial scale turbines, right? The big wind turbines are located typically in these states because there's a lot of wind here where the converging winds take place. You also have a lot of good wind on the water, right? Around the Great Lakes, right? You also have a lot of good wind on mountaintops, a lot of good wind in the east. So you can see winter wind throughout the United States. A lot of places have good wind. But how do you know if your house, your area where you live specifically has good wind? Well, we have a resource for you. It's through AWS True Power, and you send us or Renvu either your decimal data coordinates, your GPS coordinates, or your address if you have one for the site, and we can send you back a wind report that tells you some good information. But this is really the first thing you want to look into, because if you don't have 4 meters per second, that's about 10 miles per hour of winter wind, then I would recommend that you just put in more solar. Talk to Renvu, say, hey, I want to do a larger solar system. Because if you don't have about 4 meters per second or greater, then you're really, it doesn't really make sense for you to go with a wind turbine. That's just the hard truth of it. Also, if you're not open to the prevailing wind and you have trees surrounding your entire property or location, that's another consideration that you got to find out. Are you going to be able to get that wind, that laminar flow, non-turbulent wind? So here's what a wind resource looks like. This is my house in Flagstaff, and you can see here is the tower height. So if you ask for a wind resource assessment, you're interested, then this is what it'll look like. 14 meters, that's 45 feet, and this is the average wind speed. So I'm kind of on the edge here, right? I'm above 4 meters per second, some months and below. Now I would put it in because I'm a big wind fan, and I do have wind. So, but this is what the information will provide you. It also gives you this. This is your wind rose. It tells you where the prevailing wind is coming out of. So you can see I'm out of typically a lot of places in the southwest. The wind is out of the southwest. So that's what it also gives you. Here is another site. Great site right here on the water. As you can see, much higher wind resource. Again, 45-foot tower height, but much higher wind speed, about 5.5 or so winter average. This is at a lower tower height, 10 meters. You can see right here, and you can see the average has come down a little bit. The 4.92, about a little over 5 for the winter, right? So tower height does matter. If you can get it up higher, that is good. And then here is the wind rows for that site, and you can see it's all over the place here from north to south, but you have good opening from north to south. So wind resource assessment is important if you're thinking about going with wind. Here's the solar day. Everybody kind of knows this intuitively, but when you're thinking about hybrid systems, you got to consider that there's a big difference between December and June for the solar output, right? That's why all off-grid hybrid systems generally, if they're smart, they size your system for December 21st, the shortest day of the year. And here is nighttime power production. We know that this is Cheyenne, Wyoming, and if you've ever been to Cheyenne, Wyoming in the winter months, you know that it blows like crazy. But that takes place in many places throughout the winter, especially if it's a decent wind resource. And here is what's called a battery performance chart. This is a Trojan battery chart, but it's depth of discharge here on this axis, and on the vertical axis it's the number of cycles. So this is basically how long your battery is going to last. So again, 50% depth of discharge is what most off-grid systems are sized for. But if you get up into this 30 to 40% range, you can see the curve steepens and you have more number of cycles. That's how long your battery is going to last. So if you add wind into the mix and you have that turbine pushing amps into your battery bank during the winter months, during storm periods when you need it, then you're going to be better off. You're going to have that battery last longer, and you're not going to have the issues with the battery. And typically when we have a lot of customers who have issues with batteries that don't have hybrid systems, it's in the winter months and storm periods. We get a lot of inquiries in the winter months. So I know I'm running a little bit late, so I apologize for that, but let's take a look at the pictures here, show you some different installations. So this is a 45-foot guide tower, 1.5 Schedule 40 pipe, and this is a small off-grid cabin. We sell guide towers because they're the least expensive way to install a turbine. There's other ways to do it as well. Here is another guide tower system in this very, very off-grid location. As you can see, very good wind resource here. Not a lot of surface roughness except for this badminton net. And this is a shorter tower, a 27-footer. This is a marine application on a 11-foot mast and stay kit. This is an air breeze on the stern of this beautiful sailboat. This is a hybrid parking lot light application. You can see the wind and the solar here. This is Jefferson County, Colorado. These are off-grid oil and gas applications and remote science applications. These are Air 30s, or excuse me, AirX Marines. Industrial applications here, we use an Air 30 or an AirX Marine. Here is a system that deploys, that drops in and deploys and is movable, and 500 watts of solar. The battery's down here, the charge controller here. You have a Roan lattice tower, self-supporting lattice tower, and then you have the stub pipe, 1.5 Schedule 40 going up into the Air 40 yaw right here. But these are just different ways to install our turbines. Over the years, many ways have been utilized. This is a mining application on a tailings pond in a mining application. Here's trailable turbines. Obviously, these tilt down when the trailer is moving, but just different ways that our turbines have been installed. This is Antarctica, the bottom of the world. You know that because the vertical solar panels here. What I wanted to point out here is we do have quite a few customers who go with multiple turbine installations. And so if you're going with a multiple turbine installation, you got to remember that there is a downwind shadowing effect from the upwind turbine to the downwind turbine. So you need to put that downwind turbine either above or below the upwind turbine, so you minimize that downwind shadowing effect. You can see that is what they're doing here in this application. And that's important to do, or you're going to get a lot less power production out of the downwind turbine. Same thing here in this buoy application. We work a lot with NOAA and a lot of science organizations that use our turbines in these off-grid buoys and off-grid science monitoring stations. And these are AirX Marines out in the middle, out in the ocean, or out, in this case, a bay, solar and wind combined together, but two different elevations here for these two turbines so that they're not shadowing each other. Telecom applications, we do a lot with telecom as well, especially in developing countries, Africa, and all over the world. Railroad applications here, they used to use a lot of propane and generators to power these remote positive train control switching applications. But now, most of the system is powered by solar and wind, so don't have to run the generators much. Good in a lot of ways. Here's a RV application on the beautiful Sea of Cortez in Mexico. And here is a very remote, as you can see, application. The turbine spinning very well, low tower, very low tower, but high wind speed environment here. Solar panel not doing as well, but turbine spinning like crazy. So want to thank you very much for your attention on the webinar today. I hope you learned something. I hope it was helpful to you. And I want to thank Renvu as well for their being on the webinar and be able to help you with your applications and your systems. So now we have a little bit of time if there are any questions that you might have.
Yeah, Ken, just a quick one. I sent you an email with my address and everything for a wind map. You mentioned that you have tower kits. I'm on your website and I don't see that. Did I misunderstand you?
Yes, we do have tower kits, and our distributors typically talk about that. But yeah, there's a 27-foot guide tower kit, a 45-foot guide tower kit, a 29-foot transportable kit, swedged pipe comes with it. And then we have a roof mount kit. Again, when you're mounting on the roof, you got to always remember the a turbulence factor there as well. And then we have marine tower kits as well. So yeah, we have a number of different tower kits that can be resourced. And all of those manuals are under the support tab under manuals and downloads. So if you go to the support tab on our website and go to manuals and downloads, you'll see the different tower kits and what they look like and all that.
So where on your site is your list of the tower kits?
We don't necessarily have a list, but we have the manuals. Our distributors all have lists of the different tower kits that they sell and they carry.
Okay.
Chris asked about links to wind maps. We don't really have wind maps. We have that wind resource assessment tool. You can get links to wind maps through the NREL site, though. That's a great resource for wind maps. But what we do is we provide that resource assessment of your particular site. And Ron asked if wind resource data is available for Canada. Yes. We have the wind resource tool for all over the world, pretty much. There's some really remote locations that we don't have wind resource data for, but most locations we do. Jim asked if this is being recorded and if he would be a little late. Yes, we'll have the recording up on our website in a couple days, and Renvu will have it up on their website as well. I'm just going down this list, you guys. Thank you for being patient with me. Yes, there are restrictions for city and county regarding turbines. That's a big topic. And typically, since we work in the off-grid world, most of our customers are not in the city. because they're off-grid. They're charging batteries, so it's not really an off-grid thing. If you're a grid tie customer, we don't really install our turbines with a grid tie application. It's off-grid typically only. I can talk more about that if you want to talk to myself or somebody at Renvu offline.
Ken, I do have a question.
Go ahead.
What is the turbines? Does it have a situation with cogging problems?
Cogging. So if there's an issue with the circuit card, cogging could be a factor. If the cogging is usually a stator issue, right, in the stator. So
Yes.
if there's a wire delamination or something like that, sometimes you can see some cogging. But typically we don't see that. The stator issues are very, very uncommon. Our stators are 20-year design life, so they're very robust. The typical issue after 6, 7, 8 years is is the circuit. You can have a circuit malfunction. That's the power electronics. So a new circuit kit is $240 retail. So that typically 90% of the time, if there's cogging or if there's issues, that'll be a stator. You'll put in a new circuit and it'll resolve that issue. But that is typically the stator will, in what we've seen in our warranty department as well as beyond in our parts and repair department is our typical life of the circuit is somewhere between 7 and 10 years. A lot of questions, a lot of good questions here on the website. Have you seen problems with gusts, overcharging batteries? No, because we shut down. We shut down at that regulation voltage set point we talked about on the webinar. If you have a very small battery bank, and thank you, Lauren, for asking that question. I didn't bring this up, but we do have a battery bank size requirement, and we recommend a 400 amp hour battery minimum for our turbine. Because you can see some over voltage issues if you have a very small battery bank. So that's why we have that 400 amp hour battery minimum. So if you have a smaller battery bank than that, then Air 40 would be a better choice, but you need to contact us if you have a very small battery bank and you want some advice on that. Don asked, will the new digital disconnect automatically turn off the system if you're not away in a storm and it comes in? No, but overspeed protection will. The wind control panel, that's a manual switch. It's a 3-position DC break before make toggle switch, and so it's manual. But the turbine will go into overspeed protection in a storm. It does that all automatically. Do you have an average cost for a hybrid system for a 1,500 square foot house? So again, if you have a grid tie house, then the turbine is probably not right for you, Joseph. But if you have an off-grid house, it really depends on your tower, battery bank size, loads. That's a Renvu question, and there's really too many variables in there to really provide an answer for you. So I would say that call Renvu and talk to them a little bit more about that. Lauren also asked about, I've had problems with Whisper 200 not breaking quickly enough. Whisper was built by Southwest Wind Power and then moved to India, and I think is being built by Luminous. We don't sell it. We don't manage it. We don't take care of it. It has a down tower controller. I can't answer that question about Whisper. So any other pertinent questions? And you guys can also, since we're running out of time and we have to jump off, I would like, if you have questions, please direct them to info@renvu.com, or if it's specific to me, you can go use my email, info@primuswindpower.com. So there are some very specific questions in here, and if you don't get your question answered, and there's some great questions, please go ahead and email myself or Renvu to answer those questions. Any burning questions out there that we need to answer right away? All right. Nothing burning. So that's good. And thank you, Rick. Mahalo to you. And Renvu, are you guys still there? And would you like to say a little something before we shut down?
Yeah, I just want to say thank you for providing this webinar for everyone. It had a lot of great information, and for a lot of the, I think there's a lot of questions in there related to like whether or not it fits really with grid tied, or how a hybrid system might be set up, and that's definitely something we can kind of go in more depth with yet. It's something that our engineers, sales engineers here have taken a look at, and I think could probably provide some info and see how or why it might work or might not work for you, depending on what your setup is. So definitely reach out to us. And specifically, there's a couple of people who are on the webinar here, Dean and Chris, who would be happy to answer some of those questions if you want to reach out to info@Renvu and direct it towards them.
Thank you so much. All right, and you guys have a fantastic day, and feel free to reach out to us about any questions you might have. Take care.